Hello guys, so welcome back to Python Basics series. We are still in part 3, that is the operators in Python. So in this video we are going to talk about the identity operators. So basically in simple terms, identity operators is used to compare the memory locations of objects to identify or to find out if the objects are referring to the same objects in the memory or the variables are referring to the same objects in a memory. We have two types of identity operators. We have the is and is not. Is returns true if the two variables refer the same object in memory, and it's not just the opposite of is. There is always some confusion when it comes to using the identity operators with the immutable object. Immutable objects are those objects whose state can't be changed after creation. For example, the immutable are like the integers, the string, the float. For example, when you create a variable x equals 5, this variable, whenever you want to, this is an immutable object. So you can't change its state after creation. And when you try to change the state of x equals 5, what you are doing, you are basically creating a new variable with a modified value. What I mean is that you didn't change the state of the variable that existed. You created a new object. So that's what immutable object means. So when you try to deal with the immutable object with the identity operators, there's something you need to understand, and which is I'm going to explain. That's why it always gives inconsistent results. So it's always preferred you use the identity operators with the mutable object. Mutable objects are there, like the list, the dictionary, the sets, like that. So the most contradicting thing here is we're using immutable objects only with the identity operators. Let me show you an example. For example, you define a string hello, then you define another string with the same object, with the same string, a variable with the same string value, and then we say like z equals x. From what we can see, these are three different variables. So we created a variable x with a string hello, a variable y with a string hello, and we created z which references the variable x. So from what we are saying here on identity, we are looking if the two variables refer to the same object. From the looks here, the only two objects that are referencing, the only two variables that refer to the same object in memory is z and x. Why? Because z is referencing x, so that means it is referencing the value of x. So y is on its own, but here this is where I'm trying to explain why we have inconsistent results with the identity operators on the immutable object. If we print by checking if x is y and print z is x, from your own view or what we expect here, x is y should print false because they are not the same object. They are not the two variables don't refer to the same object in memory. But you'll see a different result. So let's run this. You see, it's saying true, meaning all of these objects are referring to the same object in memory. What we are saying about the memory is, whenever we create a variable, the value of a variable is stored in a memory. You see, it's always stored in a memory. So you can get the memory value by this way, using the hex ID, get the memory value of x, get the memory value of y, get the memory value of z, like that. And you can see all of these variables are referring to the same memory location. So that means all of these variables are refer to the same object in the memory. But this happens whenever you are running a program with these variables already defined and already initialized with the same string or values. But when you run a program for user to enter the string from the input, after the now you after you run the program and you ask the user to enter the string from the standard input, you'll find these two x and y will refer to the to different memory locations, and this always happens because of the optimization techniques in Python. Python is a high level language, so you don't have to mind about the memory management. So it does the memory management on its own. So this optimization technique in Python, it's called interning. When you create variables from the start, when you're creating, for example, here you created x and y, and they have the same variable values. So what it does, it makes them point to the same memory location because they were created before the program was run. So they will have to point to the same memory location. So it's a memory management technique, basically for optimization in Python. So the method is called interning. Let's see now if they will refer to the same memory location if the user is asked to enter the text from the standard input, and what will happen if the user enters the same text from the standard input. Enter text like that. So we are going to refer. So let's see. Enter text. We're going to enter hello. You see, now it prints false. X and Y refer to the to different objects in memory. You see, this is the memory location for X. This is the memory location for Y. Of course, Z and X will always be the same because Z is referencing. It's referencing. We didn't copy the value of X to Z. Z is referencing X. So this will always print the same memory location. So, but why you see now, after you ask the user to enter the input, after the program was run, you see the result is different from when the two variables were defined before the program was run. So that's the how the difference comes with the while learning, we're using identity operators on with the immutable object. But this is not the case when you are using it with the mutable. So I say the mutable objects are those objects you can change the state after creation. That's the mutable. So we are going to use the mutable. The mutable here is like the list. So let's define a list and let's use the list. Let's split two lists and ensure both of them are have the same number of elements. So like that. See now x and y for the mutable objects, it's always consistent with the results. So you see now x and y, even though they have the same even though both of them are listed with the same number of elements, the same types of elements, they are not referencing to the same memory location. Each of the lists are referencing to its own memory location. And as you can see, of course, Z is referencing to X. So that's how we use the identity operators to check if the variables refer to the same object in the memory. So it's not, of course, is used to check if the two variables is just the opposite of is. For example, here is returning false. So it's not is we are expected to return true. So x is not y. So we expect it to return true. This one here. So, and that's all for the identity operators in Python. That's how you can use identity operators. Just basically use, they are not used to compare if two variables are equal. So for that, so don't confuse the identity operators with the equal to operator or equal operator, which is a comparison operator. So we are not comparing in terms of equality. We are comparing in terms of memory location. Are they differencing to the same memory location. So that is it for the identity operators. So understand how they operate with the immutable and mutable objects. So you have to understand that to avoid the inconsistency, especially with the immutable objects. So, and that's all for the identity operators in Python. I hope you enjoyed the video. And if you did, please like the video and leave a comment. Tell me more about how the video was to you. And please don't forget to subscribe. See you in the next video. Thank you.